Everyone, welcome to evaluating definite integrals using geometric areas. This is Nicholas JMV. We are on now our last example here. So we're going to evaluate each integral below. We have this function f of x in blue here. And the first thing you're going to notice is this is an example where we have some negative area. So this is really going to be net change. It's not going to be the total area. So you got to be really careful. So let's go ahead and evaluate our integral. We're going to start from 0 to 2. Okay, so if I go ahead and look, we're going from 0 to 2 first. So there's a lot of ways you can do this. Okay, so I can go ahead and draw this down, and I can do this a couple of ways. I can do this using trapezoids. Okay, if we went ahead and went like this here, we could go trapezoids. We could also do a couple geometric shapes like this. Okay, so if we called all of this area 1, okay, so we'll call it A1 here. This whole thing is A1. But it's broken up into two pieces. So A1 is going to equal, well, we could do the area of the rectangle first. It's going to be length 2 by 1, so that's going to be 2. Plus, we're going to add to that, now we have a triangle here with base of 2 and a height of 2. So you're going to add to that 1/2 of the base, which is 2, times 2. Okay, so this ends up being 2 plus 2, okay, which is 4. So if I make a note, we're going to use this later on. A sub 1 is 4. Okay, in our second example, we're going to go from 2 to 7. So we notice we can go from 2 to 7, it's here, 2, 2, 2, 2, and it's going to stop right there at 7. And we notice we have two geometric shapes. We could call this A2, that's a triangle, and we could call this A3. I don't know if I can write it that small, A3, there we go. And so these are right triangles, okay? So let's go ahead and use the right triangle idea. So our area is going to be 1/2 of the base, which is 2 to 5, which is 3 units. That's a 3 units, okay? Times our height, which is 1, 2, 3 units, okay? So that's going to give us a decimal, plus we're going to add to that. Now this is where you got to be careful. Do you see now, notice we have area below the axes? A3 is going to have a negative area, okay? So if we still do the 1/2, okay, and you're going to do length of 2 and length of base of 2 and height of 2. So it's going to be 2 times 2. So you got to be really careful here, and I'm going to go ahead and simplify this, and you get 9/2, which is 4.5. Now here's where I'm going to throw my big minus sign in. I didn't do that right here in purple. It's going to be minus 4 over 2, which is 2. We're going to have minus 2 because that's a negative area, so we're going to take that away. So our area is actually 2.5. Okay, so if you wanted to do the area of 2, A2, which is this one, it was 9/2 or 4.5. Okay, I guess I could use the right color. And A3 is -2. Okay, so now the last example we're going is from 0 to 9 of fx. We're doing the whole thing. Well, we've got 3 of the areas, so far we know it's going to be 4 plus 4.5 minus 2, and then we're going to subtract off again. We're below the axis, so this last answer is going to be minus something. Okay, so here is our last something from 0, this is the last little piece we need. Okay, it's a rectangle. It's 7 to 9, which is 2 by 0 to -2, 2 by 2, which is 4. So we're going to subtract off 4 at the end. And so we get 4 plus 4.5 is 8.5, minus 2, 6.5, minus 4, which is 2.5. Okay, so these are not total areas because you have negative area, but it's the net change in the area is 2.5 from 0 to 9. That's the total not total area, just the net area over that time. So anyway, that's example number 2. If you guys have any questions or comments how I set this up, go ahead and type them below. And